thing then that I want to talk about is scientific notation, which again should be review for you. Hey, scientific notation is set up in the form where it's some number times 10 to some power, where the number that's written in front has a single digit in front of its decimal. And so this is the condition to represent that. The value C has to be greater than or equal to 1 but less than 10. It has to have a single digit in front of the decimal. Okay, so if we were going to take this first example here and rewrite this in scientific notation, what we would do is we take all of the digits that fall either out or after in the case of an exceptionally small number, or I'm sorry, before all the digits that fall after the zeros in an exceptionally small number, or all the digits that fall in front of the zeros in an exceptionally large number, and just write those digits. So for part A, we're going to write the digits 2, 3, 4. In order to meet this condition, you simply put a decimal point after the first digit, and then times 10 to the power of, and then what you're going to do is you're just going to count from the original number. If we had our decimal after the first digit, how many places would we need to move it to the left or right? So here we moved it left 1, 2, 3, 4, 5, 6 places. 6 places to the left. To the left is a negative direction, and so this would be the scientific notation for part A. Okay, part B is an exceptionally large number. We're going to approach it the same way. Take all the digits, this time that fall in front of the zeros, place a decimal after the first digit, times 10 to the power of, and now again we're going to go back to our original number and we're going to count out if we had a decimal in front of this first digit, how many places do we move it to the right in order to arrive at our original number? And we move it 1, 2, 3, 4, 5, 6, 7, 8, 9 places to the right. To the right is a positive value, so we leave it in that form, and that is our simplified or our scientific notation. All right, on your TI-89, on the TI-89, the scientific notation can be done a couple different ways. If you want everything to be displayed in scientific notation, you could change the mode of it. So if I go into this mode button and I come down to exponential format, the default is normal, but if you turn it into scientific, it'll give you every single answer in scientific notation. So if you're really struggling on scientific notation, you'd probably want to go into this. It would help you figure that out. Now, hopefully you don't need to do that. Hopefully you can, the conversion into scientific notation should be something that you can do by hand. Okay, but if not, you can change the whole mode. All right. The button on your calculator that represents this whole portion right here, times 10 to the power of, is this EE button. It's right next to the 4. So if you wanted to type in the answer to part A in scientific notation on your calculator, you would type it in as 2.34. You'd hit this EE button, so we get 2.34. The EE button results in a display of just a single E. Okay? It's the scientific exponential format. Okay? And then you type in what the power of the negative, or what the power of n would be. So you get e to the minus 6. Okay? So 2.34 e to the minus 6, again where the e is this EE button, that represents this particular number. Okay, do make sure that you use the change of sign key rather than the subtraction key. And you have to use, if you put the subtraction key here, it won't allow you to do this. Okay, and so for the second part, 3.551 EE, which results in a display of e to the 9, would be how you'd enter that number. So 3.551 EE 9. So that's this number. And again, you can see it displays that. Okay, so what I would like you to do is just take a moment and see if you can answer questions A and B from sample problem 6 using your calculators. All right, I'll just kind of start talking through A. For A, what I'm going to do is I'm going to rewrite each of those in scientific notation first and then enter them on my calculator. So this 50 million, I have one digit, 5, times 10 to the power of, count how many I need to move over. So 1, 2, 3, 4, 5, 6, 7 to the right gives me 5 times 10 to the 7th. I'm going to multiply that by, I only have one digit at the end of this exceptionally small number. So I write that digit, move the decimal 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 places to the left. Oops. So I get 10 times, or 6 times 10 to the minus 10. And then my number in the denominator, I have one digit 2 times 10 to the power of, and move it over 1, 2, 3, 4. And that's all going to be cubed. So here's all my expression, all my numbers in scientific notation. If I calculate this, I get 5e to the 7th times 6e to the negative 10. Divide by, now my whole quantity in the denominator is going to be cubed, so I'm going to put that in grouping symbols. So 2e to the 4th, and that whole thing is going to be cubed. And so when I enter this, I get my answer 3.75 times 10 to the minus 15. All right, for B, this one's already written in that form, so all I need to do is enter it on my calculator. So I have 3 times 10 to the negative 5, so that's 3e negative 5. Times here, this whole quantity is going to be cubed. So since I'm cubing the whole quantity, I do want to put that in grouping symbols. So 6e to the minus 3, all cubed. And then I'm dividing that by, in the denominator, 9e to the negative 12, all squared. Once I enter everything, I can calculate it. It gives me my answer. Here I have 8 times 10 to the power of, and just count how far to the right I need to move my decimal. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 places to the right to get my solution. And now, a problem like B is potentially one that you might see and be expected to do by hand. And if you're approaching this one by hand, here's what I would expect you to do. And what I would do is kind of group things together here. So if I'm looking at B and solving this by hand, in the numerator I have a 3 and I have 10 to the minus 5. Next I have this 6 cubed. So the way I'm going to express it is just 6, 6, and 6. But then the 10 to the power of, I'm going to go ahead and apply the rules. So when I take a power to a power, what do I do with the powers? Multiply. So negative 3 times 3 is negative 9, and that's all divided by, here I'm going to square the 9, so I have 9 times 9, and then do the same thing with my 10 to the negative 12 squared. What do I do when I take a power to a power? Multiply. Okay, so in looking at this, what it allows me to do here is to simplify a little bit, because I have this 3 cancels with the 9, leaving a 3. This 3 cancels with 6, leaving a 2. Remember, there's 2 3's in this 9. One of them cancels with this 6, leaving a 2. One of them cancels with this 6, leaving a 2. So across my numerator, I have 2 times 2 times 2. So I have a total of 8 times. And now, if I move this factor of this base of 10 up to my numerator, I change the power of its sign, or change the sign of its power. I now have, multiplying here, 10 to the minus 5 plus a minus 9 plus a 24, or again, I could have left it down here and said minus a negative 24 becomes a plus 24. And if I simplify that, negative 14 plus 24 gives me 10. And so you should be able to do a problem like this without using a calculator.